Hi, I'm Jeff Dillon, Technical Support Engineer for Couchbase. I'm here to present Couchbase in the Loop and show how Couchbase can be used in many areas in science and engineering. I will be presenting two examples where Couchbase is ideally suited for auditing and storing sensor data. In this age of the Internet of Things, sensors are everywhere, and Couchbase is in a perfect position to store that data and make it available in the cloud. Our world is becoming more and more connected. Here are just some of the areas where Couchbase could be used in the loop. Being able to smartly monitor and audit this increasing volume of data is vital to our better understanding and management of the world around us. As a distributed, persistent document store, Couchbase is the ideal solution in these environments. With Couchbase in the loop in environmental applications, it could be used to monitor air pollution, snow level monitoring, forest fire detection, and an earthquake early detection. Monitoring of water level variations in rivers, dams, and reservoirs. Energy consumption monitoring and management and monitoring of water, oil, and gas levels in storage tanks. Perimeter access control and distributed measurement of radiation levels in nuclear power stations. In retail applications, Couchbase could be used in warehouse automation and monitoring of storage conditions along the supply chain. Monitoring of container flow and search of individual items in big services like warehouses and harbors. Control of temperature and sensitive devices along the assembly line and auditing of machine-to-machine communications. Control of microclimate conditions in greenhouses and monitoring of weather conditions and soil moisture. Control of growing conditions in animal farms and location tracking and identification of grazing animals in open pastures or large stables. Energy and water supply consumption monitoring and remote control of energy-saving appliances. Monitoring of vital signs and exercise activity. Monitoring of available parking spaces and traffic congestion, and monitoring of vibrations and material conditions in buildings and bridges. The drone industry is emerging as a multi-billion-dollar market, and increasing regulations are inevitable. These drones often use GPS to calculate their position and velocity. Accurately calculating the flight path of the vehicle is important, as well as providing an audit trail of where it's been. In this example, I will show you how I used an onboard positional sensor to send data to Couchbase and make it immediately available in the cloud for analysis. I'm using an Arduino-style embedded system that sends position data via local Wi-Fi network to a host system running Couchbase. So this is the Arduino system. It's got an onboard XB and Wi-Fi module, lithium-ion battery. So it's running a small version of Linux. It's not running Couchbase Lite. It does what it does best. Monitors sensor data, in this case accelerometer data, and then 10 times a second it sends an acceleration vector via UDP. And that is received by a client, either a PC or a mobile device, which in turn runs Couchbase. So this device just rests piggyback on the quadcopter. And so as it moves up and down, it sends its acceleration data 10 times a second. So I have the iPhone Wi-Fi app here, so I press takeoff. On the left you see the UDP listener, and on the right operations per second. And landing. Here I have the Node.js UDP listener and the Couchbase admin UI. And when I move the device, you see the UDP messages coming in and updating the operations per second graph. Here I have the source code for the Node.js application. We have a couple of requires, set some variables, then we make the Couchbase connection. Then when the UDP message comes in, we write the key value to Couchbase. With the positional data stored in Couchbase, a client application could then go in and perform an audit on the drone's flight path. It would be possible to develop a 3D view of the geospatial information in Couchbase for subsequent visual and mathematical analysis. Using machine learning with Couchbase in the loop, one could iterate the design into more complex systems, such as a drone-enabled personal escape system. There are also space applications. The need for monitoring space weather conditions is becoming important as more and more people are experiencing the opportunity of personal space travel. Space weather, for the most part, is the effect that the sun has on the Earth environment. We see this effect in the aurora borealis in the northern latitudes. Solar flares, for example, can have detrimental effects on global communications and can disrupt electrical grids. They can also impact astronaut safety and disrupt electrical systems of orbital spacecraft. Couchbase is partnering with several companies along with NASA who are offering an application to track the ongoing effects of space weather. Whether tapping into the NASA licensed up-to-the-minute online datasets or reading from a nearby sensor via Bluetooth, the ARMIS app tracks this information for personal use. Some organizations, such as commercial airlines, require their employees to monitor this information and stay within prescribed limits. On the right, we have Virgin Galactic Spaceship 2 and the X-Core Lynx. Aboard these suborbital vehicles will be a radiation sensor that will capture the entire particle and photon environment, leading to personal exposure, including heavy ions, neutrons, protons, beta particles, gamma rays, and X-rays. This sensor will broadcast this data to Couchbase Lite running on mobile devices operated by the pilots and passengers. Let's take a quick look at how Couchbase is heading to space. This is the X-Core spacecraft, offering $100,000 rides to the edge of space. From a runway takeoff, the vehicle rises quickly to an altitude of about 100 kilometers or about 62 miles. There, the pilot and passengers experience a few minutes of weightlessness before a re-entry and a runway landing. Couchbase is in the loop, monitoring and storing sensor data captured during the flight. The ARMIS app and Couchbase Lite are also used on domestic and international flights by frequent flyers and flight crews. The extensive library of current NASA space weather information is available via the ARMIS API when real-time sensor data is not available. During certain conditions, a coast-to-coast airline flight, for example, could be the equivalent ionizing dosage of a chest X-ray, and Couchbase makes it possible to track and analyze this information. This is Jeff Dillon with Couchbase. Thank you for joining me. See you next time.